Welcome. Let's go ahead and get started. Today, how about you start off by practicing this problem, getting ready for our upcoming exams. A baseball player hits a ball that follows a parabolic path modeled by this equation. Find the maximum height of the ball, and what is the horizontal distance traveled by the ball when it's caught. Hit pause, figure it out, come on back and check. All right, welcome back. So, a parabolic path. We're going to hit the ball, it's going to go kind of like that. We're looking for the maximum height. Maximums occur for a parabola, and it is a parabola, it's f squared, at where? The vertex. So, find your vertex. Formula for vertex. X is equal to negative b, the opposite of b, divided by 2 times a. A will be negative 0.02, B would be 4, there is no C. So, negative 4 divided by 2 times negative 0.02. Put this in a calculator, you will get your X value, but the X value is not the maximum height. The Y value is the maximum height. The X just tells us how far out we go, but we still have to figure out how high it is. So negative 4 divided by parentheses, 2 times negative 0.02. X is 100, take your 100, plug it in here and here, we'll get our Y value. Negative 0.02 times 100 squared plus 4 times 100. What is the horizontal distance traveled by the ball when it's caught? Well, if you think about it, we just found that the distance from here to here is 100. So, what's going to be the horizontal distance? 100 plus 100 would make 200. No, your vertex and your horizontal distance are not always going to be the same. It just happens to work out that way. I picked nice, easy numbers to use. Let's go ahead and hop into our notes. Today we're in Chapter 9, Section 2, finding coordinates of points on the unit circle. So our unit circle, we have to keep in mind, is just that. It is a circle. And if you think about a circle on an XY plane, then where is the center of this circle? Well, it'd be right here at 0, 0. And then for each point that's actually on the circle, they would be equidistant from that center. That's what makes a circle. So we would have a radius. Being a unit circle, we're going to consider the radius to be 1. So what I'm saying is, from the center to here is 1 unit. Same here, same here, same here, same here, same here, same here, same everywhere all the way around. That's important. Keep in mind, your radius is 1 unit. For a circle, our equation would be x squared plus y squared equals r squared. Well, 1 squared is 1. So we get x squared plus y squared equals 1. That's giving us our center of 0, 0, radius of 1. So if this is 1 unit from here to here, that gives me a point right here. And that point would be x is 1, y is 0. Then we would have a point all the way up at the top. We would go up 1 unit. We're not going left or right any. So this point here would be 0, 1. From the center, go left 1 unit. What would be the coordinates of that point? You're going left, so now we're in a negative territory. That would give us negative 1, 0. How about down here? What would be the coordinates of that point if we went down 1 unit? 0, negative 1. We didn't go left or right any, we just went down 1 unit. So you can think of it as being on an XY plane, because that's exactly what it is. Any triangle that we make in that unit circle is going to have a hypotenuse that we know the value of. So let's think about that. Let's say that I'm sitting here and I go up a certain amount of degrees, don't know what it is. But from here, I go to here a certain number of degrees. Well, from that point at the top, if I were to drop straight down, we would end up forming a right triangle. We always stand up straight, so there's my right triangle, right? You always stand up straight when we're measuring a height. So from any point on the circle, I could draw a right triangle. Your right triangle should always go to the x-axis, by the way. Never draw it horizontally to the y-axis. Always with the x. Why? Think about it. You don't lean, you don't lay down, you stand up straight. So we want our height to be standing up straight, not laying flat, not leaning in. You're getting your measurement of your height of your triangle. We're creating an angle here. This is going to be our angle. We'll call it theta at some point. But how big is the hypotenuse? How big is from here, the center, to the edge of the circle? Well, it's a radius. It's 1 unit. So any right triangle that I draw in that circle, doesn't matter what the angle is going to have a hypotenuse of 1. Let's take a look at the best website ever. It's called Math is Fun. Gives us the unit circle for cosine, sine, tangent, and so on. There we are. Unit circle is a circle with a radius of 1. We've got our points here. We've got a radius of 1. And again, you could go straight down, you would get a right triangle. So here's our unit circle. We need to pay attention to the different answers up here for different degrees. We have cosine, sine, and tangent. So as we move from no triangle because there's no height to now we do have a height. The height is the green. As it gets taller, the width in blue gets more narrow. So as one gets taller, the other gets more narrow. As we go around, as the height gets shorter, the width gets longer. So they're always moving in an opposite inverse fashion. Well, as you look at it, the blue is a width of 0.669. Well, cosine of that angle, 48 degrees, is 0.669. So what this is trying to tell you is that if you have a right triangle, that width, which is our x value, is going to be the cosine. The height, which is the y value, right? Y's go this way, x's go this way. The height, the y value, 0.743 for that angle, 48 degrees, is sine equal to 0.743. Don't worry so much about tangent right now. Tangent is simply sine divided by cosine. But you can see outside, the gray, that's your tangent line. A tangent line is something that touches in one place. So for any angle, the height is going to be our sine, that's our y. The width is going to be our x for cosine. So let's see if we can do a little labeling here. Okay. Got our unit circle. we know we go out 1 unit this way, up 1 unit this way, left 1 unit this way, down 1 unit that way. And if we were to draw any right triangle in here, maybe this one, we would be creating an angle. We'll call it theta. That was an awful theta. Sorry. Let me redo theta. Looks like an O with a belt. Our Greek letter theta. There's our right angle, letting us know it's a right triangle. So the hypotenuse is across from it. How big is the hypotenuse? Well, it's a radius, so therefore it should be equal to 1. This is my x, this is my y. Remember, x is this way, y is this way, just like on a coordinate plane. So if we were to define things like SOHCAHTOA using a right triangle, sine of my angle theta would equal opposite over hypotenuse. Which side's the opposite? Here's your theta. Opposite would be y. Hypotenuse is 1. Well, anything divided by 1 is itself. So you could say that the sine of that angle, theta, is equal to y. It's equal to the height. However tall that triangle is, that is our answer for sine of the angle. Cosine of theta. Well, now we're talking about adjacent over hypotenuse. Adjacent is the x, hypotenuse is 1. So x over 1 is equal to x. A very easy way to remember this is to think of it this way. You have x and y. It's a point, right? Alphabetically, x comes before y. Alphabetically, cosine comes before sine. Cosine is the x, sine is the y. Cosine comes first, sine is second. Say that. Sine is second. That will help you remember when we have a point with an x and a y value that the first number is the answer for cosine. The second number is the answer for sine. That brings us to tangent. Tangent of theta is opposite over adjacent. So opposite is y, adjacent is x. Y over x. But you know what? Y is equal to sine. So you could say that tangent of theta is equal to the sine of theta divided by x. X is cosine of theta. This is the trig identity. We use it a lot. To find our value for tangent, we often find the answer for sine. We divide it by the answer for cosine. The good news is it's often a fraction or has a radical in it to figure these out, so they get to be fun. Let's see if we figure it out. If you have an angle named Jarene, you have sine of Jarene, and you have cosine of Jarene, guess what you get? You get tangerine. Get it? Here we go. Here's a new one. Sine of angle B divided by tangent of angle B. Well, I thought tangent was equal to sine divided by cosine. So if I were to cross multiply and I switch cosine and tangent, that would tell me that cosine of B is equal to sine of B divided by tangent of B. That's what we have. Sine of B divided by tangent of B is Cosby. Bill Cosby. He was an actor, comedian. He got in a little bit of trouble a few years ago, but yeah. Let's find some of our answers for sine, cosine, and tangent. Keeping in mind that sine is equal to the y, cosine is the x. Tangent will be y divided by x. If we're thinking about 0 degrees, 90 degrees, 180, and 270, well, we know that this over here is 90 degrees. let me rephrase that. This over here is 0 degrees. I can't believe I just said 90 there. My bad. 0 degrees. 90 is up top. 180 is over here. Half a circle. 270 is down here. 90, 90, 90 more. And it gets us back to 360 here. So whatever the answers are for 0 degrees is going to be the same answers for 360. They're coterminal angles. They have the same answers for sine, cosine, and tangent. Let's talk about 0 degrees. Our point, 1 unit out, would be 1 comma 0. So if we were to find the sine of 0 degrees, keeping in mind x and y, cosine is first, sine is second. Cosine is first, it's the x. My answer is 1. Sine is second. My answer is the second number, 0. To find tangent, we would take sine divided by cosine, y divided by x. 0 divided by 1 is 0. My next point, 90 degrees, straight up. 0 comma 1. X is 0, y is 1. 90 degrees. X is 0, y is 1. To find tangent, we would take sine divided by cosine. 1 divided by 0 is undefined. You get a vertical asymptote there. You cannot divide by 0. Let's move over to 180. 180 is over here. My point is, yes, -1, 0. X is -1, y is 0. Divide them, you'll have your answer for tangent of 180 degrees. 0 divided by -1 is 0. My last point, 270 degrees, straight down. We've got 0, -1. X is 0, that's my cosine. Sine is second, sine is the y at -1. And if I want tangent, I take -1 divided by 0, which is undefined. We have yet another vertical asymptote. You cannot divide by 0. This is really the linchpin to understanding it all. Keeping in mind, cosine is your x, sine is your y. Cosine is first, sine is second. If you know that, you can label your points, just thinking of a unit circle, 1 unit out, and you can get your answers for sine, cosine, tangent of any of those angles. Homer and Lisa have very different ideas about pi. Which one do you think about? Yeah, I'm kind of there also. I'm a math teacher. Of course I have problems. Ha! How about you guys? 15 minutes max, no more. You get done when you get done and move on with our notes. I'll wait here, you hit pause, come on back. All right, guys and gals, welcome back. Let's talk about how do you know when sine and cosine will be positive or negative, because we're not going to do just these angles, 0, 90, 180, 270, 360. We're going to end up getting any angle in between. Any angle in between. So they end up in different quadrants. If we think about an angle that's here, well, my x is positive, my y is positive. If I think instead about an angle that's over here, well, my y is positive, but my x is now negative. Thinking of that right triangle that you would be drawing. X would be negative, Y would be positive. Well, that tells you sine and cosine are going to have different signs. I'll let you think about which one's going to be positive, which one's negative. And the same thing would hold true down in quadrants 3 and 4. If I go here for my angle, well, it gives me a right triangle. There's my angle, my reference angle. What do you know about y? Well, it's down below. It's negative. What do you know about x? Well, it's to the left. It's negative. So think about which functions will be positive and negative in those quadrants. Let's take a look at that Math is Fun website again. So in quadrant 1, you'll notice that your x and your y are both positive. Well, x is cosine, y is sine. So looking at our angles, guess what? They're positive. They're all positive. Even tangent, because a positive divided by a positive is a positive. But when we go to quadrant 2, we have that negative x value. So cosine becomes negative. Sine is positive. Why is tangent suddenly negative? Well, because tangent is a positive divided by a negative. Let's go below the x-axis. Well, now x and y are both negative, makes cosine and sine negative. But two negatives divide, make a positive. How about quadrant 4? Well, x is back on the positive side, so cosine's positive. Y is down in negative territory, so sine is negative. Therefore, tangent's negative. You have opposite signs, they're going to turn out to be negative. So, what's an easy way to remember this? All year long, we practiced and studied for our ACTs. In quadrant 1, they are all positive. In quadrant 4, only cosine is positive. In quadrant 3, only tangent's positive. That means sine and cosine are negative. In quadrant 2, only sine is positive. What does that tell you about cosine? Yeah, it's negative. What does it tell you about tangent? It's negative. So this tells you which function is positive for an angle in that quadrant. ACTs. That'll help you remember it. Last thing we're going to look at today is how to find some values for cosine and sine of 45 degrees. And any other reference angle that would fit it. So let's talk 45 degrees. Splits it in half. Here's 45 degrees. If I were to draw a right triangle, assuming I'm dealing with a unit circle, that would make my hypotenuse still 1. How big are the sides? Well, if it's a 45, 45, 90, this and this should be the same value. Right? X and Y are going to be the same. How big? Well, you had 45, 45, 90s. In a 45, 45, 90, we learned that you've got side, side, then we multiply by radical 2. We take our side, these are the same, we multiply by radical 2. If we're starting here, we would do the opposite. Instead of multiplying the side by radical 2, we take our hypotenuse and divide by radical 2. So this will be 1 divided by radical 2. And if you're thinking, we can't leave it there, Mr. Brown, it's not rationalized. You're right. You don't leave a radical in the bottom. Let's multiply by radical 2 over radical 2. So 1 radical 2, over square root of 2 times square root of 2 is square root of 4. Anybody know the square root of 4? Yeah, it's 2. So our x is radical 2 over 2. Our y is also radical 2 over 2. And what that does for us is it gives us our answers for sine and cosine. Come on, I know you're over here somewhere. No? Really? I thought for sure I had it written. Darn, I gotta actually write that. Sine of 45 degrees. Opposite over hypotenuse. Opposite, radical 2 over 2. Divided by 1. Dividing by 1 doesn't matter. Remember, sine is your y value. Cosine. Cosine is your x, adjacent over hypotenuse. Radical 2 over 2, divided by 1. Dividing by 1 doesn't matter. Cosine is your x. So both of these are radical 2 over 2. How would you get tangent? Well, you take sine divided by cosine. What's anything divided by itself? Okay? Think about that. I'll do it the long way. Radical 2 over 2 for sine divided by radical 2 over 2 for cosine. Keep, flip, change. Pretty sure 2 cancels with 2, radical 2 cancels with radical 2, so the answer for tangent is equal to 1. When you have 45 degrees, sine and cosine are the same. Anything divided by itself is equal to 1. What about 315 degrees? First of all, which quadrant is it in? 45, 90, 135, 180, 225, 270, 315. Okay, 315 would be here. From here to here is 315 degrees. What is our reference angle right here? Well, this is 360, this is 315. If I subtract them, it's a 45-degree reference angle. If this is 45, this is 45. X and y will be the same thing. What are they? Well, cosine and sine of 45 degrees. It was radical 2 over 2 and radical 2 over 2. But keep in mind, hypotenuse is 1. Keep in mind, x is positive here. Y is negative because it's down below the x-axis. So if we were to think of our sine of 315, cosine of 315, and our tangent of 315, we should be getting the same answers as 45 degrees, but one of them might be negative, two of them might be negative, right? It depends on what quadrant we're in, but the answer should still be radical 2 over 2, radical 2 over 2, and 1. Which quadrant are we in? We're here. A, C, T's. In this quadrant, only cosine is positive. Sine is negative, tangent's negative. Look at it, negative y value. That's why sine's negative. Positive x value. That's why cosine's positive. Why is tangent negative? Take a negative divided by a positive, you'll get a negative. $225, 45, 90, 135, 180, 225 is here. Draw your right triangle. How big is our reference angle? Well, this is 180 up to 225. Yep, 45 degrees. As soon as you know that, your answers are the same. Sine of 225, radical 2 over 2. Cosine of 225, radical 2 over 2. Tangent, 1. Now let's talk about who's positive, who's negative. All are positive. Only cosine's positive. Only tangent's positive. Only tangent, right? Only tangent. You're negative, you're negative. The x is negative, the y is negative. How about you guys practice a little bit unit circles, 45, 45, 90. Find your reference angles. Figure out, is it going to be positive or negative? That's going by your ACTs. Have a great Viking day. See you guys next time.